We're back, baby. Oh, yeah. Hello. It is fantastic to see you all. And yes, welcome. Welcome to NDC. Welcome to Oslo. Welcome to Computational Creativity. My name is Dylan Beattie, and this is what I look like when I'm stuck in my house wearing a headset for 18 months. I am the director and founder and chief everything officer at Versatile, which is a training and strategy consultancy company that I started at the start of last year so I could do lots of travel. That was the worst idea anyone ever had. I'm a Microsoft MVP with the Developer Technologies program. I run a London.NET user group, and I do dumb things with computers just to see if it will work. As I walked in, someone said, "Are you the guy who wrote the song about the bad APIs?" Yeah, I write songs about bad APIs, and I write songs about code, and sometimes I write code about songs, and I spent a whole bunch of my life going, I don't know if I want to be a programmer or a musician. And eventually I thought, we should just mash these two things together and invent a programming language where you can do both at the same time. Which is not what I'm going to talk to you about today. You'll hear some bits and pieces about that over the next couple of days. But if any of you does want to go on LinkedIn and apply for all of those sweet rockstar developer jobs, go to codewithrockstar.com. And you can write programs in the Rockstar programming language, which I invented in a bar as a joke. And now it's a joke with a formal reference implementation and a test suite. And I am the project manager of the joke, which is a weird thing to do with your weekends. Now, the last 18 months, you've all been bored off your ass. And do you know how I know that? I did a talk at NDC London in January 2020, all about Rockstar and esoteric languages and that kind of stuff, and they put it up on YouTube, as they always do. And that talk has had something like 3 million views, which is, you know... Now that's, you know, if I ever need to impress a teenager, I think that might be useful. I'm not really sure what you do with 3 million YouTube views. So yeah, a lot of people have watched that video, and a lot of people got in touch and said, is there any more? And I'm like, oh, there's so much. Like, you know, you take all the good ideas you've ever had, and you have to cut out everything which won't fit into a 1-hour talk. And you get so much interesting stuff and ideas and perspectives that get kind of, you know, left on the cutting room floor. And so what this talk is about, computational creativity, is a sort of... It's some of those ideas that didn't quite fit what I wanted to do with Art of Code, and it's just an exploration of some of the things that we humans can do in all kinds of, you know, creative endeavors, movies, music, film, writing, problem solving, using these wonderful digital computer tools that are ubiquitous now. And I was reading this book a little while ago. Anyone know Sid Meier? Anyone play any of his railroad? Yeah. So this is his... sort of biography, and it's very cool and very nerdy, and he talks about him and all the people he's worked with, the games they've worked on. And I had already come up with the title for this talk, and then as I was reading this book, I found this little snippet in there, and it talks about computational creativity. It uses exactly that same phrase, and he's talking about, they wanted to write a mystery game where every time you played the game, it gave you an original, like a fresh mystery to solve. And he has this wonderful tone of phrase in here. He says, it was only a little bit impossible, which is not the same as completely impossible. And, you know, I love that idea of looking at the boundaries. You know, what do we think is impossible to do? What do you just go, oh. But, you know, there's things which it would take a sort of paradigm shift in our understanding of the universe if we were able to do that. And there's other stuff which is like, well, it's impossible, but... if we got a slightly faster machine and a better camera and we cheated a little bit with some of this, maybe we could do that. And so those are some of the ideas that we're going to be exploring today. And we're going to start here. We are going to start about 40,000 years ago. This is a cave painting that was discovered in Indonesia in 2019. And what I find amazing about this, one, it is believed to be the earliest example ever of human beings creating art. Certainly the earliest example that has survived. So this is kind of, you know, very shortly after the first human being kind of, you know, got some mud and went, oh, I can make a mark on a wall. They're like, I can draw stuff, and I can depict the world around me. And by the time they got to the end of this art, they're like, I can make things up. Because if you look very closely, this is a scene of a hunt. But one of the hunters is a human being with a tail, and another one is a human being with a head like a bird. And so this idea, as soon as human beings learned how to create things, we started to use them to make things up and tell stories, and use, fiction and creativity as a mechanism to explore the world around us. Now, art has a heritage going back, 40,000 years. We've come from this through the invention of, painting, sculpture, sketching. We've got artists Michelangelo and Da Vinci, Frida Kahlo, Hokusai, all these kinds of things. And in the mid-18th century, so we're talking about, the mid-19th century, the 1840s. I hate the way historians do that, because the first century is the one that starts at 0, not at 1,000, right? So yeah, 19th century, 1840s, there was a group of artists in France called the Realists. Now, most painting up to that point was very glamorous paintings of rich people, or it was paintings of God and Jesus and saints, because those were kind of the people who could afford art. And the realists were like, we are bored of that. We want to paint reality as accurately as we can. We are not interested in, gold leaf and stylized things. We want to paint, pictures that show people what real life actually looked like. The realism movement survived for, decades. It proved quite influential. And then in the second half of the 19th century, a technological innovation came along that basically wiped out the realists and changed the world forever. It was the invention of photography. Now, why would you labor over painting an incredibly accurate picture of some poor people digging up a field when you can just go and take a photo of it? Photography gave us a way of capturing the world around us that, it wiped out one art form. It eliminated realism as a painting style, as a school of painting. But it allowed us to start capturing images like these ones, pivotal moments in history. This famous, the milk drop experiment of showing really, really fast shutter speeds, giving us this insight into a world we'd never been able to see, because we just can't look fast enough until we use technology to help us. And so next time you and your friends are out and you're in a bar and you are taking selfies. Now this photograph, I found this by typing drunkest picture ever taken into Reddit. And you can't imagine the realists sitting down and painting this. But next time you snap a picture like this, just take a moment and remember the realists who tried to do this using pens, paintbrushes and oils and all those kinds of things. Now, photography was just one example of a load of different technologies that emerged over the course of what we call the Industrial Revolution, kind of 1760 until the middle of the 19th century. Textiles was mechanized, agriculture, mining, manufacturing, transportation, hundreds and thousands of human endeavors, things people used to do because there was no other way to do them. Suddenly, those things were getting automated. And the effects of that, the impact of those changes on our society is still visible today, all around us. Now, you have probably heard the word Luddite at some point in your career. The Luddites are, last year the Luddites are the people who still can't figure out Zoom, and they want everyone back in the office, and it's like, no, come on, just work a camera, it's not that hard. But Luddite has been the sort of slightly derogatory term for people who, I don't really do email, I don't like computers, I'm not sure about cars, I want to go to work on a horse, that kind of thing. And the Luddites are named after a person. They're named after this guy in this picture. This is Ned Ludd. And Ned Ludd represented a bunch of weavers who thought that looms, automated textile looms, were a threat to their livelihood, and so they went around smashing them up with hammers. And so what this depicts, new technology comes along, and there are always going to be people who embrace the possibility. They just see this as, wow, there's all this new stuff we can do. And there are the people who go, I don't like that. It's going to take our jobs. I don't like change. I don't like it when, we have progress going on in society. That's not really my thing. And they will resist that, and they will oppose that. Now, the people in this picture are computers. Until about 1950, the word computer, it existed. We had computers in English. It was a job. Computers were people who, this is NASA. All of these people worked at NASA in the 1950s and 1960s. So the time of, the first American space launches, the Apollo missions, the origins of things like the Space Shuttle program. And these were people who did calculations. That's what a computer was. It's a person who did sums for a living. Now, you've probably seen, there's a movie came out a couple of years ago called Hidden Figures, which was based on a true story about a group of African-American women who were working at NASA during the 1950s. And you probably remember this scene. Now, calculation is most calculation, the kind of calculations that they're doing at NASA, that was not a terribly creative form of mathematics. They were crunching numbers to work out what their spacecraft needed to do. How long do we burn the engines? How heavy can this component afford to be? And, those kinds of calculations were obviously ripe for automation because it took a long time to do them. Now, the woman talking on the blackboard there in that clip, Octavia Spencer is the actress playing her. The character is called Dorothy Vaughan, and she's a real person. She worked at NASA from the 1950s until 1971. So while she was working at NASA, human beings walked on the moon. We invented the Hewlett-Packard 35 pocket scientific calculator. We invented the Intel 4004 microprocessor, the Xerox laser printers, ARPANET email, and by the time she left, computer was not a person anymore. Computer was a machine. It was a calculating device. Now, those innovations, like I said, calculation wasn't really, these people were like, this could take our jobs. So we have more interesting stuff we could do with our mathematical skills. And when you solve 2 + 2 = 4, there isn't really much of a question about who takes the credit for that result, especially if you're doing the maths to try and beat the Soviet Union to be the first people on the moon and win the space race. Now, when I was a kid, we were not allowed to use calculators in school. We were taught how to use them, but the teachers were like, when you grow up, you are not going to have a calculator in your pocket. Hands up if you've got a calculator in your pocket. Yeah, I'm sorry, Mrs. Marshall. I think we've won that one. But you had to learn your times tables and that kind of stuff. But I was because I was a nerdy kid, I was one of the early adopters. I was one of the only kids in my school who did their homework on a word processor. Everyone else did it by hand. And I had these long arguments with teachers about whether I was allowed to use a spell checker. Because on the one hand, the teachers are like, no, you need to learn how to spell all the words. And I said, well, what if I don't know how to spell the word? And they said, well, look it up in a dictionary. And I was like, but if I don't know how to spell it, how am I supposed to find it? Do I just start at the beginning and dig? And also, the dictionary tells you what words mean. Why would I be using a word in an essay that I don't know what it means? And we engineered this very, very weird compromise. I was allowed to use the word-perfect spell checker for geography and history, but I wasn't allowed to use it for English. I was not allowed to use a spell checker for English because my English teacher was like, well, no, I'm teaching you English, so that would be cheating, but you can use it in all your other classes, and I don't care. And, we ended up with this sort of, like I said, weird compromise. But all a spell checker can really do is it can look at the words that you've given it, and it can say, do those words appear in this list? Using some form of case-insensitive, accent-insensitive collation, I would assume there. If you want to know what that is, come to my talk tomorrow, you can learn all about that. Now, the problem with spell checkers, they don't know what the words mean. They don't actually solve any problems. They just tell you, does that pattern of characters appear? And this problem has been immortalized in this wonderful poem by Gerald Czar, Ode to a Spell Checker. I have a spelling checker. It came with my PC. It plainly marks for my review mistakes I cannot see. I strike a key and type a word and wait for it to say. Whether I am wrong or right, it shows me straight away. Now, when I wasn't arguing the merits of spell checkers in Mrs. Jones' English class, I was doing what teenage kids did in the 1990s. I was riding bikes, and I was playing guitar and going to the movies. And in 1991, the movie everybody was talking about was Terminator 2 Judgment Day because it was brilliant. It had a killer robot from the future, and then it had a killer robot from the future who turned out to be one of the good guys. And it had Arnie, and it had motorcycles, and it had Guns N' Roses on the soundtrack, and it had this thing. This was something none of us had ever seen on a cinema screen before. The T-1000 liquid metal hunter-killer Terminator robot. Now, the special effects which allowed them to realize scenes like this one here from Terminator 2, they had a budget of $5 million. 36 people worked for a year on just the T-1000, just that liquid metal effect. It was absolutely pioneering. It won the Academy Award for Best Visual Effects and, plaudits from throughout the industry and stuff, but it was not the first time somebody had used a computer to make a movie. In 1982, unknown director, a guy called Steven Lisberger, created a movie called Tron. Now, Tron was massively controversial because they used computers to make the film. Now, Tron was produced by Disney. It was distributed by Disney. It was paid for by Disney. It was not made by Disney because Disney's animators refused to work on it. they boycotted the project and said, we are not going to animate a project that uses computers because we think they are a threat to our industry and our livelihood. So all the animation, the hand animation in Tron, was actually done in Japan. Now, you know, Tron mixed, it was fascinating what they did with it. It had a mixture of live action footage, hand-animated animation, and about 20 minutes of completely computer-generated animated scenes. And of course, the first law of Hollywood is if there's an explosion, you have to have a tire bouncing out of it. That's just the rules. Now, if you watch that clip closely, they did not have the technology to mix live action and computer animation. So whenever you see a human actor's face, all of the kind of computer graphics in that have been drawn by hand on top of the film cells. But the scenes with no humans in them, those were animated entirely on a computer. Now, Tron was one of the most innovative and visually stunning movies ever made. It was not nominated for an Academy Award, let alone winning it. It was disqualified because the Academy of Motion Picture Arts and Sciences said that using computers to make movies was cheating. Now, the weird thing was, there was already a precedent. They were quite happy if you had a computer in your movie with computer graphics in the movie appearing on the computer screen that was in the movie. So films like Alien, where they have computers in them, they're like, oh, that's fine. You know, you're allowed to do that. But the thing was, doing computer graphics was actually incredibly expensive. Take a look at this scene. This is the glider approach sequence from John Carpenter's Escape from New York. So we got Kurt Russell as a Snake Plissken who's being sent to New York to rescue the president who's been kidnapped. I don't actually remember the plot of that movie very much. But if you watch this scene closely, you see that there? The green screen wireframe view of him coasting in over Manhattan? They couldn't afford to do that on a computer because they just had a Hollywood motion picture budget. You couldn't get enough computer time. That scene was shot in a soundstage. So they got a big room, kind of like this one, big dark room. They covered the floor in black felt, and they got a load of cardboard boxes. They painted them black, and they ran green neon piping around the edges. They put an ultraviolet light up so all the green glowed, and then they just walked a camera through like this. And that's how they got this gliding effect. And the person who created that effect was James Cameron, who went on to do Terminator and Titanic and Avatar and all those kinds of movies. Now, most of the time in Hollywood, if you wanted to do computer graphics, you faked it because it was easier to hire people to draw the computer graphics. It's how they made Max Headroom. It's how they did all the computer graphics in the Hitchhiker's Guide to the Galaxy TV series. But Tron was like, we are actually going to make it using a computer. And they did it on this thing here. This is the Foonly F1. It was a one-of-a-kind overclocked PDP-10. It took 6 hours to render a single frame of footage. It, like I said, couldn't combine live action. So anything where you had a human being, they'd kind of give the computer graphic to the animators and say, we need you to paint this onto here. And they did it. Now, like I said, Tron was disqualified. Eventually, 20 years later, the Academy went, we might have made a mistake here. And they awarded Tron a lifetime achievement for innovation in cinematography and computer graphics. But by the time Terminator 2 came along, the balance had flipped. You know, computers were widespread in movie and cinema, television production, and they made hard things easy, and they made some impossible things not quite so impossible anymore. And they started raising some really interesting questions about who actually created the scenes that audiences were seeing on their cinema screens. Now, in scenes like this one from Peter Jackson's Lord of the Rings trilogy, all of those orcs on that battlefield there, they are not just kind of computer-generated characters. All of their behavior is being generated. The computer is doing the acting. and the computer is doing the costumes, and the computer is doing the choreography. It's a system they created called Massive, the multiple agent simulation system in a virtual environment. And all of those have got, just like, bots in Quake deathmatches and stuff, they've got some relatively simple behavior that just is very, very well rendered. And there's a lovely story, if you've seen the third Lord of the Rings movie with the giant war elephants that come on. The first time they ran that scene, a bunch of the soldiers turned around and legged it because their programming said, "Get off this battlefield, you are in danger." And they came out a bit later and they're like, actually, that was just a bug. They were programmed to find an empty area if they couldn't get to where the action was. But by that point, the story was out, and so it's a good opportunity to retell it. But, we're getting to a point now where you can render just about anything. If a filmmaker can imagine it, computers can realize that, and they can get it on a screen, and you can look at it. And a couple of years ago, we met this guy. Now, who is that? Well, there is an argument that says that is Moff Tarkin. He's a fictional character owned by Lucasfilm Limited. He's copyrighted, and they are free to do whatever they like. And there is another school of thought which says, no, that is clearly a digital reproduction of a dead British actor called Peter Cushing. And we are starting to see actual lawsuits about these kinds of things. Now, in this particular instance, it was all done, there's a snippet I want to show you. This is from an ABC Nightline feature about how they did that, how they created that Peter Cushing effect there. Now, if you think we can go too far, yes, we can. Look at this. This should never have happened. This was an abomination against human decency, But this is the point. There are no constraints now on what filmmakers can do. If they have an idea, I read a review of the recent Star Wars trilogy, which said, we've got living actors playing dead characters. We've got dead actors playing living characters. It's at a point now where even death is not a barrier to becoming a Hollywood star. But we're getting to a point now. I was at a DevOps in the UK a couple of weeks ago, and there was a team there showing off real-time deepfaking for video calls, which is some really kind of sinister and quite scary technology, because that's, at the moment, it is impossible to do that convincingly, but it is only a little bit impossible. It is not completely impossible. And we are going to start seeing all kinds of stuff coming out with deepfakes and digital avatars and all these kinds of things. And it raises some very, very important questions that we need to start thinking about.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, Killmonger was right. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet.
Now that there is the perfect storm threat model, because deepfaking speech is difficult. Because speech, people talk at different speeds. They talk faster, they talk slower. So if you have a voice impersonation, you can tweak the stuff with technology a little bit. But, you imagine somebody like, you got Matthew McConaughey, who has this kind of very laid-back Texan drawl accent, and you want to deepfake him to sound like Joe Pasquale. He talks really, really fast. You can't do it. Because you can't do it fast enough, because you don't know what Matthew McConaughey has said yet, because he hasn't got there, so you can't translate it and put it at the right point. But if you have people who can do vocal impressions, and you run that through motion capture, you get this kind of deepfake video technology, you can produce even real-time video clips, which will probably fool most people as to who it is they're watching and what that person is actually saying. Now, one of the big questions that is being raised online is, who's responsible, who's liable for this kind of stuff? If, in the age of print media, if somebody printed a story that wasn't true, I could sue them. And this was well established because they're a publisher who has made a decision. Somebody who is an individual who is liable under the legal system and can be called up to appear in court has said, yes, we will run that story. We'll sell a bunch of newspapers and it'll probably make us more money than we'll lose in the ensuing lawsuits and fines and stuff. And for a long time, there was this open question about how is this going to work on the internet. In the 1990s, it looked for a little while like websites and internet providers could be held liable for anything that was transmitted across them. So let's say you go on Facebook and Mark has put a comment on Facebook where he says something about me that I don't like. So I'm like, all right, I'm going to sue Mark Zuckerberg because Facebook made that possible. And we honestly didn't know. There was this open question, is a website a newspaper or is a website something more akin to a telephone line? Because those were the legal precedents we were working with. Now, Section 230 of the Telecommunications Act in the United States is this: no provider or user of an interactive computer service shall be treated as the publisher or speaker of any information provided by another information content provider. So what that means is if I put something on your website and someone else doesn't like it, they can sue me, but they can't sue you. Websites are like the postal service. They are considered neutral, and the content that's on there is they're considered to be, transparent, what they call common carriers in some places. But, we're entering this kind of murky area now where it used to be just most websites were just a big bag of information and they'd show you whatever it was that you could find. But now we are getting curating algorithms. We are getting things like social media feeds which are deciding what they're going to show you. And that's not a human editor making an editorial decision about what content to run. That is an algorithm that is going in and saying, we think you'll click on this. We think that person is going to click on this. And for a while there, if you went onto Twitter, it would show you top tweets first. And every couple of days you'd go and switch it off because you don't want top tweets first. And every couple of days it would switch it back on. It's like, oh no, we think you really do want top tweets. That's what you want. And, this is algorithmic. It's optimizing for advertisers and advertising revenue based on user engagement. And it isn't like you can go to the editor of Twitter and call them and say, we're going to sue you because of what your algorithm does. Now, how many of you watch YouTube? And when you get to the end of a YouTube video, there's a recommendation. Have you ever seen a recommendation that said, that's enough YouTube for today? Like, YouTube's algorithm, the ideal, the perfect score for that algorithm is somebody who one day they get a laptop, they open it up, they go on YouTube, and they never go outside again. That is the behavior it is optimizing towards, because all it's doing is saying, watch another video, watch another video, watch another video. It doesn't have anything else to recommend. All it's got is videos, and the more you watch, the more, algorithmic doggy treats or whatever they use to train these things that it gets. Now, I'm not saying this is complete doom and gloom. I do actually love recommendations because I use Spotify a lot, and Spotify keeps popping up these little daily mixes, which are mixtures of songs I love, songs I forgot I loved because I've not listened to them in 20 years, and new music and new releases from bands that I didn't know about and all that kind of stuff. And one of those YouTube recommendations that popped up for me last year was a guy in Switzerland who just restores machine tools in silence. And it's brilliant. There's no music. There's no dialogue. It's just him in his workshop. You never see his face. And it's like these 20-minute, very zen videos of him fixing up old tools and planes and vices and stuff. And I'd never have found that if it wasn't for the recommendation algorithm. But we have these increasingly powerful and sophisticated algorithms that are being deployed in all kinds of scenarios. And they raise questions about, who's responsible for the behavior of those algorithms, who gets the credit if they do something good, who's liable if they do something bad. But it also raises the question of, can we trust the platforms that the algorithms are being deployed onto? Anyone ever heard of Knight Capital? In 2012, Knight Capital was the single biggest equities trader on the New York Stock Exchange. In first quarter of that year, they did nearly $300 million of equities trading. 17% of all the trades on the NASDAQ stock index went through Knight Capital system. And they had a piece of software called SMARS, S-M-A-R-S, which was automated software for doing very, very rapid stock exchange trading. Now, in 2012, there was a bunch bunch of laws brought out, something called the Retail Liquidity Program, which effectively relaxed some of the regulations around being able to connect automated systems directly into the financial trading backbone that runs the stock markets. And Knight Capital, they took their smart software and they got a team to do a bunch of work to upgrade it, to incorporate all the new rules. And on August the 1st, they ran out the upgrade. They deployed this upgrade onto 8 servers, the 8 servers in their trading cluster, except they actually only deployed it onto 7. Now, buried somewhere inside the code of SMARS, there was a thing called PowerPeg. And PowerPeg's job was, if you said, I want to buy 1,000 shares of that company there, nobody would be selling 1,000 shares, so PowerPeg would go, okay, we'll get 200 from them, 50 from them, 150 from those people, and it would put in these trades until it reached the limit, and then it would switch the thing off. Now, PowerPeg had been removed. It hadn't been used in 9 years, but it hadn't been removed. It was still there. It was disabled. It was disabled by a feature flag, and all the people who were working at the company in 2012 didn't know what that feature flag was for because none of them had been there when it was used. And this was the flag that they used to turn on the new stock exchange rules, the retail liquidity thing. So they deploy the new code onto 7 servers, and then they flip the config on 8 of them, and one of them wakes up this dormant code from 9 years ago, whose job is to buy and sell things on the stock exchange. Now, it had a safety check that had been commented out. It had been removed from the code, because, well, no one's using it. You know, it's going to be removed any day now. It hasn't been used for years and years and years. They had created an infinite loop plugged into the New York Stock Exchange that spends real money. The first thing they did was they went, oh, crap, this is really bad, and they rolled the old software back onto the other 7 servers, but they didn't reset the flag. So now you have 8 infinite loops plugged into the New York Stock Exchange spending real money. It took them about 45 minutes to figure out what was happening and shut the thing down. And the Security and Equities Commission report, these are normally very, very dry, but this one is actually funny because it summarizes it as Knight Capital had accumulated an unintended multi-billion-dollar portfolio of securities in approximately 45 minutes. They did. They ultimately lost nearly $500 million on the back of that computer mistake. And they had to pay a $12 million fine, because obviously that's really going to sting when you've just lost $500 million, because not only is what they did incredibly stupid and negligent, it's also a criminal offense to deploy the wrong software and, you know, mess up the stock market the way that they did. But, you know, who's to blame? There's an engineer whose job was to roll out that code onto 8 servers, and they only rolled it out onto 7. Does that sound like a $500 million mistake? You know, I've made mistakes like that. Unfortunately, no one's ever come after me for $500 million. The developers who reuse the feature flag. You ever reuse the flag in software because the process to get a new one is going to take 3 months and you have to have this thing live now because of the new financial regulations? That sounds like a situation a lot of us has been in. You know, maybe somewhere in a meeting, someone was like, we really shouldn't do this, and the boss went, no, it's all right, it's on me. You just go ahead with it, I'll get it sorted out. And of course they never did. It never happened. You know, who's to blame there? Who accepts the liability? Now, as developers, we're used to shipping software that eventually goes on and sometimes makes somebody else an awful lot of money. And we don't necessarily go, well, actually, you give me all of the money because that's my code that made all the money for you. And the flip side of that is when our code makes a mistake that loses someone a lot of money, we're not normally personally liable for that kind of thing. Now, this wiped out Knight Capital. That's a graph of their stock exchange price. They crashed. A competitor came along and basically bought them for pennies, and that was it. Knight Capital now exists in history as a fun company to talk about in talks about what happens when algorithms go wrong and how to scare stockbrokers. But the thing about that scenario is that even though it was this incredibly high-speed automated trading solution, it was still possible to work out what had happened. You could draw a line between, okay, this order came in and it went to that trade and that got split and that got split. And you could sort of do a forensic analysis and figure out, now this happened, it's doing stuff human beings do, but it's doing it in milliseconds instead of hours. And that was kind of the problem here. But they were fundamentally just automating a process that was familiar to a majority of the people who work in that industry. Now, there are 2 things that are true right across the technology sector. One of them is that recruitment is a massive pain in the ass. Looking for a job sucks. Finding developers sucks. Everything about recruitment is horrible. And the other one is that if we see a problem in our industry, which is a massive pain in the ass, we try and automate a solution so we don't have to do it anymore. And about a decade ago, Amazon tried this. Amazon set out this in 2014. They hired a team to automate recruitment. And the data set they gave them every single CV, every single resume of anyone who had applied for a job at Amazon within the last 5 years, along with the data on how far they got through the interview process and whether they subsequently got offered a job. And so they ran a whole bunch of different neural networks and machine learning models across this thing. And basically their brief was, we hired these people, find the patterns so we know what we are looking for. And it worked. They found some patterns. They read something like 500 different models. They discovered that if you had been to a women's college, you probably did not get a job with Amazon. They discovered that if you had been to certain community colleges, you were getting downgraded and were not getting a job with Amazon. People from certain geographic districts were getting ranked down and were not getting jobs with Amazon. And the people who did get jobs with Amazon was a total crapshoot. They had nothing in common whatsoever that could be distilled from the information in those CVs. Now, the algorithms worked. What they did is they uncovered a pattern, which was you have some serious systemic bias in the way that your hiring practices work, and basically you reject the people you don't like based on your cultural prejudices and then randomly hire somebody from the pile that's left. Now, Amazon are adamant that they never actually did this. They never used it to hire people. It was an experiment. It taught them some stuff about themselves, which I'm sure they went away and did the responsible thing with. But you know, this is a big deal. When you're building any kind of machine learning system, you're reliant on data to train that model and help get it right. And getting data that doesn't reflect cultural biases turns out to be very, very difficult. Now, a little while ago, Twitter had this wonderful feature that if you uploaded a photograph that had some people in it, it would try and find a person and it would kind of crop in on their face when you were viewing it in the Twitter web feed. And it turned out that, well, it kind of worked. Like, it found people's faces, but it was overwhelmingly favoring particular kinds of people's faces. It was favoring white guys all the time. Anything the Twitter algorithm believed to be a white guy would be prioritized regardless of the composition of the image. Now, I ran a whole bunch of pictures through this to kind of get an idea for it. So Brad Pitt and Jennifer Aniston, whichever way around you put them, Brad always gets the spotlight on that. If you upload Bender from Futurama in the same picture as Jacinda Ardern, the Prime Minister of New Zealand, Twitter's algorithm goes, oh no, Bender's got a facier face than that other person. We're going to crop and highlight on that. Now, you know, I don't think anybody sat down on purpose and went, let's write a really sexist, racist algorithm and put it on Twitter for all our users. I think what has happened here is a bunch of engineers, they got a data set. Now, it's an unfortunate fact that most of the photographs in the public domain are of white men, because most of the famous people in our society are white men, because we elect white politicians, and we go and see films starring white male actors, and we watch Olympic Games and sporting events. And so those kind of celebrities tend towards a certain, you know, ethnicity and gender bias. But there's 8 billion people on this planet. And, you know, I know gender and ethnicity are not absolute concepts, but I'm pretty sure if you said, right, everyone who's like, yeah, I'm a white guy, you all come over here, you'd end up with about that many people relative to the rest of the human beings on this planet. Now, what that means is that if you build a facial recognition algorithm which is 98% accurate on you, the 10 other white guys on your team, the 5,000 white guys in your photography data set, and a couple of your sample groups, your algorithm is only 9% accurate because you've only tested it on this tiny little sliver of population. Now, this is a problem, you know, and I don't think it's a problem that necessarily arises out of malice or intent. I think all of the people who build these algorithms are genuinely trying to solve a problem that they see, and they're trying to do it in a way that works as effectively as possible. But they are being hamstrung by the fact that there are these biases in the data. There are biases in the teams, and there's biases in the way that society informs the work that they do. So, you know, we can fix it. First of all, we do need better data. If you're doing anything with machine learning, look at where the data came from. And, you know, look at that data and say, is there any possibility that this has been biased in favor of famous people, wealthy people, rich people, employed people, college graduates? Look for those kind of biases in your data sets. Better teams, you know, have somebody in the room or on the Slack with you who you show that and they go, hey, you know what, I just ran your algorithm on me and it didn't work. And they'll be like, oh, that's interesting. You know, let's dig a little deeper into why maybe this thing isn't working for everybody. And we can make a better world, you know. I'm completely up for trying to do that. Now, we have accomplished some absolutely astonishing things. You look at the impact that technology has had on us and the society that we live in, the world all around us. The last 18 months, we've been doing conferences like this. And if you'd said to me 2 years ago, you're going to do a conference, but no one's allowed to travel anywhere and you're not even allowed to go outside, I'd have been like, no, we're not. But we made it happen. We have the technology, we have bandwidth, and we have cameras. And one of the things that I think is absolutely wonderful about the world we live in is that the cost of access to information has just been coming down and down and down and down. If you need to repair a tractor, or you need to set a bone, or you need to identify a parasite that's been eating your crops, you can look that stuff up online right now. For free. You can get a $100 smartphone, or you can get a second-hand smartphone, or you can go to a library and use a terminal, and all that kind of stuff is available anywhere, and people can get access to answers to questions. Now, when I was a kid, I grew up in Southern Africa. I grew up in Zimbabwe, and if I had a question, I could ask a grown-up, or I could go and look in the library. I basically had access, my parents and the stuff they knew and the books they had in the house. There was the library, there were my teachers. Now, the kind of questions that mattered to me as a kid were questions like, who would win in a fight between Optimus Prime and Darth Vader? And the Borrowdale School Library was woefully lacking on appropriate reference material on this front. But, I had a pretty privileged upbringing. I was like, what is the fastest anyone has ever ridden a BMX? What do you mean you don't know? Come on, that's got to be in here somewhere. But there are kids out there all over the world right now who have really important questions about, their identity, healthcare, how they fit into society. And once upon a time, they probably have spent their whole lives just miserable in some small town somewhere going, I don't belong and I don't fit in and I'm really unhappy. And now they can go online and they can why am I different? And they'll get people all over the planet going, hey, you're not different. It's just there's no one else is interesting you in the town where you live. It's fine. There's loads of us. Come out and meet us. It's going to be okay. And I think that's worth it. I think that's absolutely worth it, and if it means we got to go through 10 or 15 years of Russian botnets and fake news and Twitter bias to maintain that freedom of access to information for the people who are actually looking for it, then I'm up for the challenge. Let's absolutely do that. Now, one of the most significant questions about computation, we've talked about calculation, we've talked about spell checking, we've talked about visual rendering and deepfakes and all these kinds of things. We've talked about machine learning, and somewhere in there is always this big question, what kind of computers are we? What kind of computational model does the human brain actually use, and will we ever be able to create an artificial one? Now, there is a lovely quote from Edgar Dijkstra, who says, the question of whether a computer can think is no more interesting than the question of whether a submarine can swim. But maybe think is the wrong word. We're English, we have this word think, and we talk about, we'll build a thinking computer, build a thinking machine. But think is just like whatever you do with your brain. It's this massive umbrella term. What do you think? Oh, where's the library? I think it's down there, 2 blocks on the left, I think. I think Jimi Hendrix is massively overrated. I think I want a sandwich. I think I love you. These are not the same process. All these different problem-solving and emotional processes that we humans go to, we call them all thinking just because we don't have any model for breaking it down into something more nuanced. But maybe we can look at a specific kind of computational process. Maybe we can look at playing a game of chess, for example. Now, it turns out the oldest chess-playing computer program is older than computers. Alan Turing wrote a chess program in pencil in a notebook in about 1948, before there were any computers in the world capable of running it. And then he went through and he executed it manually using a pen and paper to keep track of all the registers, and wrote up some notes about this is actually quite good. And about 3 decades later, somebody implemented it, and they found a couple of bugs, but it worked. It was a working chess-playing program written for a computer that didn't exist yet by somebody who never actually got to run it themselves. Now, the first computer chess championship was held in 1974. And in 1974, most computers, a decent human player could beat any chess computer out there. But computers got better and better and better and better. In 1990, when was it? Deep thought, 1989. Garry Kasparov, Russian world chess champion, or Soviet at the time chess champion, he played a machine called Deep Thought, which was an IBM supercomputer, and it managed to force a draw. So he had the best human chess player in the world being forced into a draw. He went on to win in the next game, but it kind of rattled him. And then about 8 years late, 1997, IBM came back with a thing called Deep Blue, and it won. It defeated Kasparov 3-2, and for the first time, a computer had beaten the world's best human chess player in tournament play. Now, from that point, it's game over for the humans, basically. Magnus Carlsen, he's Norwegian, isn't he, Carlsen? And he says, I don't bother playing computers because it's no fun. You know, I'm the best chess player in the world, and they just kick my ass every time. And it's not even interesting. But there was a little period, a little while there, where Magnus Carlsen Kasparov, Garry Kasparov, became interested in something called, some people call it hybrid chess, some people call it centaur chess, some people call it cyborg chess. And basically what it is each player is a human with a computer. And so you've got a human being using a computer to go, is this a good move? Is that a bad move? And then using that to play. And for a while there, before the supercomputers kind of, accelerated and took over, we had this weird situation where, a reasonably good, we're not talking world champion standard, a reasonably good human chess player with a laptop could beat international grandmasters and the chess supercomputers. Because something about that synergy of human creativity and mechanical calculated problem solving gave them a competitive edge. And the really interesting thing about that, if you read the stuff that Kasparov wrote while he was working on this, he believed that the discriminating factor wasn't the quality of the human player or the quality of the computer, it was the quality of the interface between them. How quickly could that human being get their ideas into the computer, and how easily could they understand the responses that were coming back from it? And, somebody who cares a lot about usability and user experience, I think that that's absolutely fantastic. This idea that the kind of limiting factor is not the humans or the machines, it's how good are we at turning machines into tools that work harmoniously with what our brains are trying to do as we try and make sense of the world around us and solve these kinds of problems. And that brings us to the home stretch, because the last thing I want to talk to you about today is exactly this hybrid creativity. Humans and computers working together to create things that would not otherwise exist. Now, a couple of years ago, some of you may have seen this guy, Mikhail Lusak. He gave a talk here at NDC, and I saw him give it at a couple of other conferences, about writing heavy metal riffs using machine learning and .NET. And I've just got a little excerpt. What he did is he downloaded all of the guitar music for the first 4 Metallica albums, Anthrax, Slayer, a whole bunch of other bands like that, and he turned it into a format that ML.NET could understand, and he ran this huge training algorithm network across it, and then said to it, I would like you to write me a heavy metal song now, please. And this is what happened. So there you go. Heavy metal riff written by a neural network based on Metallica songs and created using some code that Mikhail put together. Now, at that point, I saw that talk and I thought, oh, this is brilliant. We need to do some stuff with this because that's how my brain works. And I started thinking, all right, we've got machine learning is capable of writing music. That's kind of, okay, we can do some stuff with that. What about lyrics? And I started digging around. Now, the state of the art with computer-generated text is GPT-3. Have any of you got access to GPT-3? No, me neither. I keep asking for it, and I think I shouldn't have told them that I wanted to use it to write Metallica songs, because I think maybe they think I'm being frivolous with their technology. But last year, The Guardian newspaper in the UK, it published an article written entirely by the GPT-3 I don't even know what to call this thing. It's a neural network, but it's like a neural network on a scale we've not really seen before. It's a natural language parser, and all they did is they said to the system, please write a short op-ed, 500 words, keep the language simple and concise, focus on why humans have nothing to fear from AI. And what they did is they ran that, I think they ran that 8 times, and then one of the editors just went, all right, that paragraph. But that's how editors put together newspaper stories. They'll take a whole bunch of stuff that journalist has submitted, they'll take that copy and they'll kind of curate it. They'll pick the best bits and maybe tweak a little bit so it flows better. And so effectively, the journalist who wrote this article, it was edited by a human, but it was written by a machine and run in a newspaper using exactly the same process that you would use to publish something written by a human. Now, like I said, I can't get access to GPT-3. I'm not sure why. I keep asking. I haven't heard anything back. So we're going to use a slightly more primitive approach to generate some lyrics for the purpose of our exercise. We're going to use something called a Markov chain. Now, Markov chains they're a lot of fun to play around with. Basically, you take a massive chunk of text, and you analyze it, and you look for patterns of words, and then you run a randomizing algorithm that puts together text that follows the patterns it found in your original training corpus, but which is original. Now, we're going to do a little worked example here. Let's say that we train a Markov chain on the lyrics to Hotel California by Eagles. And then we're like, right, we want you to write us a line of Eagles lyrics. And so we say, okay, we're going to start with the word she. Now, in Hotel California, she does a lot of things. She stood in the doorway, and she lit up a candle, and she showed me the way, and she got the Mercedes-Benz. And what the Markov chain is going to do is it's going to pick one of those 4 words at random. What did she do? She showed. Yeah, there we go. All right, stick showed in there. And now we're like, okay, go back to Hotel California. What words could come after showed in that piece of text, in that bit of writing? The only one we've got in there is she showed me the way. So that's got to be me. That's the only thing that follows it. Now, what comes after me? Well, she showed me the way. Please bring me my wine. So we've got the, or we've got my, 50-50, toss a coin. She showed me my, and what are my things in Hotel California? Well, I had the cool wind in my hair. My sight grew dim. Please bring me my wine. Pick one of those at random. There we go. She showed me my hair. Which is nonsensical, but it's nonsensical in a kind of, if Don Henley sang that in 1970, you'd probably just accept that he'd written it, right? Now, there is a site out there called lyrics.rip, which has basically built Markov chains for every single band by getting all of their lyrics. And it will just generate, you go on this and like, go and make me some Metallica lyrics or some AC/DC lyrics. And there's a guy on YouTube who has taken a bunch of these. Funk Turkey is the name of the channel. And he takes these Markov chain lyrics, but then he writes all the music himself to go with it and puts up these videos and stuff. And so what I wanted to do is I wanted to take Mikhail's TensorFlow and machine learning model, take the music from that, Markov chain some Metallica lyrics. Now, there's a little bit of curation involved. I hit the refresh button about 20 or 30 times, and I picked lines and paragraphs that worked well together and looked out for some patterns. But what I did, I took the thing, I put them all together, and because I was in lockdown, I sat around for a bunch of time. Now, I'm not going to play this one live. You want to see live music, come and see the party tomorrow, mainly because I don't really want to bounce up and down on this stage very much. But here you go. Take a listen to this and tell me what you think. And so there you go, friends, the music of the future. written by a website with music generated on Mikhail's laptop, lovingly curated by me and the Lockdown All-Stars there. It's my green screen band. That bass player is a jerk, he really is. Thank you very much for coming along. Are there any questions? You'll need to shout, because I can't see you. All I can see is the lights. But if there's no questions, it'll be just like doing this on Zoom, where there's never any questions. It's like, I don't know any questions. Oh, no, you went to get a biscuit. All right, never mind. Cool. All right, thank you very much for coming along, folks. Yeah.
I have a question.
Yes.
Have you heard any songs recently that you've suspected may possibly have been written by an algorithm?
So you know the whole Turing Test thing about, one day we will build a machine that is so smart that you can no longer distinguish it from a human being. Unfortunately, my theory is that the Turing Test is not going to get passed by machines getting smarter, it's going to get passed by people getting dumber. And I have certainly heard music written by people that they probably should have written with an algorithm. There's quite a lot of that in the charts most days. No, I mean, there's stuff, probably got an app on your phone. If any of you got an iPhone, there's a thing on there now where you can just sing into it and it'll generate backing for you by doing like a harmonic analysis of your voice and putting in chords and drums and all that kind of stuff. And, I've used algorithmic drum loops and stuff in music I've done. I'm absolutely certain if you put on the radio for half an hour, you're going to hear something in there, which maybe not an entire song generated by an algorithm. And, I think most lyrics are still being written by people by hand. But, music lyrics are nonsensical. You stop there, it sounds like nonsense, but it's very Metallica-y nonsense. And if they put that on an album, you're probably just going to go, all right, wow, this is so deep. I wonder what the hidden symbolism of all these kinds of lyrics is. But I'm sure, it's only a matter of time before we have a completely, digital simulated celebrity who has simulated algorithmic music, at which point it's like, well, who owns it? Where did that come from? Is it the person who wrote the algorithm? Do they get the royalties? Is it the person who programmed the avatar? Is it the person who owns the hardware that the whole thing is running on? Because, music copyright in particular is very, very weird, because to copyright a song, you have to write it on sheet music. If you haven't written it on sheet music, you can't copyright it as a songwriter. And you ever go and see, when you go and see a Lucasfilm movie, they used to have that THX noise, like that huge, and the whole cinema would shake. This is really cool. And they went to copyright that, and the Library of Congress said they couldn't copyright it because it didn't have a score. And so Ben Burt, who's Lucasfilm sound designer, he wrote the most messed up score you've ever seen on one page of stave music, and then he sent it to the Library of Congress and went, this is the THX deep wave noise, please. I'd like to be registered as the writer of this piece of work. And they went, oh, no problem, Mr. Burt, thank you very much. So there are some really, really kind of interesting questions around, credit and copyright and liability and all this kind of stuff. But, don't let the scary questions detract from the fact that there is awesome new art and music out there, which we've not thought of yet because we've never had the technology to explore these things before. And I'm sure it'll only be a matter of time before some of it makes it into the charts. Not that anyone listens to charts anymore, but, hey, Any other questions, folks? Yeah, I see a raised hand.
Did you ever find out who would win between Optimus Prime and Darth Vader?
You see, I have access to a lot more material now. Like, really, when I was a kid, I think I had 2 Transformers comic books, and I had what I remembered from seeing Return of the Jedi at the drive-in, and everything else was my friends and I going, I reckon Darth Vader's got an electric space horse. And everyone else would be like, oh, wow, he knows a lot about that. We had no idea. I think it would have to be Darth Vader because, Optimus Prime is still constrained by the limits of physical reality because there's no magic in Transformers. They're just really clever machines. I mean, Arthur C. Clarke's definition of magic. Whereas Darth Vader's got all that crazy force stuff. And so he could, force push Optimus Prime off a cliff and game over. So, yeah. Evil will always win because good is dumb. All right. Thank you very much, folks. Anybody who's coming to the Christmas dinner, I'll see you at the Christmas dinner. If not, we're back tomorrow for some more. Take it easy. Have a good evening.